PostgreSQL creating database with SQL query and set primary key constraints.
Hello friends, welcome to another video of the PostgreSQL series. In this part, we will learn how to create table in PostgreSQL database using SQL query. So the table that we created in the previous part, if you will try to create same table with the help of a SQL query, so it will look something like this. So what you have written here is you have to write create table and then you have to write the name of table. So create table, table name. The table name here is TBL hotel and public. This is our default schema in which we are creating our table. Now next thing is we have ID, we have integer. So ID is integer and it is not null, generated always as identity, increment by 1, start 1, minimum value 1, maximum value 10 and cache of 1. So we discussed these things in the previous part. What is the meaning of increment, start, minimum and maximum value? Name, character varying and length, maximum length is 100. It is not null. And pin code was integer. Phone, character of length 15. Writing length for character and character varying is very important. And we set the constraint TBL hotel underscore P key and we set primary key as ID column. So this was for previous example. Now let's see what we can do now, how we can create a table. So first I will create a very simple table here. So to create a very simple table, what you have to do, let's say we have to create a table called user here. So you have to write create table and then you have to write the name of that table. So if you want to create it in the public schema, you will write public.user. What is meaning of schema? Why we are saying this term schema? So you will get a separate chapter for that in which I will explain you the meaning of schema. In this case, you can simply consider it as an account in which we are creating these values. So we are creating table user. Let's say in table user we have two columns ID. So ID is integer, it is not null, and we have name. Name is character because it's of a string data type, and let's say name will have a maximum value of 50. So this is the simple and most easy way of creating a table. Copy this and open your pgadmin. In your pgadmin, go to tables, refresh. In tables, bring your query tool. Your query tool will come. This is query editor. In your query editor, paste this simple table. So in this simple table, you can see we are creating a table which is called user. We are creating this table in public schema. That's why we have written public. If you will not write this, then also it will be okay. But writing this will make sure that it will be in public schema. Then we have ID, integer, not null. This is the data type of ID. And then we have name, character 50. In this case, we did not set any primary key. We have no more constraint here. We just have one constraint, and that is not null. Now select this, execute this using this arrow, and you can see query written. And now when you will refresh this, so that table will be created. So now you have two tables, one is table hotel and another table is users, and in your users table you will see there is a column and you will see there is no constraint. So this is a simple example of creating table. Now we have to create our TBL rooms now. So I have written this SQL query here. So in TBL rooms we have to create table public dot tbl underscore rooms. The first column will be room ID, it will be integer and not null. So you simply have to write this. First you have to write the name of the column, then you have to specify the data type, then you have to write whether it will be null or not null, and then you have to put a comma. After this, you have to write this thing in this parenthesis or in this round bracket. So between the opening and closing round bracket, you have to write name of these columns. These are just comma separated values, you can see. So create table public dot tbl underscore rooms, and then you are creating these values in a sequence. The first you are writing the name of column, then data type, and whether it will be null or not null. Similarly, we have room name here. Room name will be of character 50. So this room name, why we are putting room name as character 50? It can be character 50 or it can be character 10 also. Let's say in our hotel, or the hotel for which we are creating this database, in that hotel rooms are named like this: D101, SD403, something like this. So the maximum value it can get, let's say, is 10, or the maximum value it can get is suppose 5. So in that case you will write 5 here. So it will depend upon the number of characters that it can get, the maximum number of characters it can get. If you are not sure about that particular number of characters, if the number of characters are fixed, you see that the number of characters are fixed. Let's say in every room there will be 5 characters like this: D0101 or SD403. There are 5 characters. So in that case you use char. If you are not sure, if you think the number of characters will vary, so for that case you will use character varying, and you can put character varying as 10. So in case of character, it will take this much space. So in case of character, it will definitely take this much space. It will take a space of 10 characters. But in case of character varying, the space it will take, the memory it will take, will depend upon the length of that particular value. So I prefer character varying, and I know that maximum number of characters will be 10, and because it's character varying, so it will take the space as per the value that will be stored inside it, and it will not be null. So this will be our room name. Then we have room price. For price, I suggest you to write a decimal value. So you can write decimal value for price, because decimal value will give you the exact value. So decimal values can be used for telling Postgre that we want an exact value here. So another data type that is used for price, or that can be used for price, is float. One more data type can be used, numeric. So in numeric also you write it like this. So either you can use float or numeric. Float is used whenever we need accurate values or nearby values, because it's floating point number. Float is not recommended for exact values. If you have to, because money is something that, suppose the price of any particular room is 500, then by applying taxes you will have some decimals also. So if you want decimals up to 4 places, so you can write something like this. So in this case, there will be total 10 characters in the digit, and out of those 10 characters in the number, out of those 10 characters, 4 will be for decimals. So you will have something like, you can write something like this: 1 2 3 4 5 6.0304. you can write something like this in this case. So we'll see that. So I think this is enough for room price. We can put decimal values here. Then we have room category here. Room category will will be character, so we'll write character here. And again, in room category, let's say we'll have something like this: DE, DE for deluxe, SD for super deluxe, or let's say SU. So let's say categories will be like this. So in such case we can put character as 2, because we know that it in this case the value will be of maximum 2 characters. So again, whatever maximum length we are putting here, this will be as per or according to the value that will come in the column. Again, with more databases that we will see in upcoming chapters, you will learn more about these data types. If you don't have to get confused about this, because the more practice you will get, the more type of databases that you will create, you will see more data types here. And I will also share the minimum and the maximum value that we can share in these various data types. For these data types, I will create a separate chapter in which I will explain you about these data types, what type of value is best, or for what type of value which particular data type is best. So as I told you, for money, decimal is preferred. You can also put numeric, but we prefer decimal here. So then more data types will come, which will be related to date and time. So we will deal with them also. So in this case, by writing this much, our table will be created. But we have not done something about the auto increment part. We have set room ID as primary key. So you can see constraint room p key. So this room p key that we are setting is the name of that primary key. So we can set any number of primary keys in a particular table. We can set 2 primary keys also. Suppose we want to set primary key on room ID and room name. What is the main purpose of primary key? The primary key is very much helpful in updating, deleting records. The primary key is very much helpful in providing a unique identity to each row that will be inserted in this particular table. So because there can be hundreds of room in this hotel, so every room will have a unique identity. So it is same as you have your government IDs and you have the identity. So I have talked about this in the previous video also. And for primary key and various settings related to primary key, you will see in various examples. So primary key is, we are setting a primary key here, and we can set primary key as auto increment also. So the example that you were seeing just before this, so after not null, you can write this. This is valid in PostgreSQL. So what we are doing here is we are setting increment 1, minimum value 1, maximum value let's say 500. Let's say in this hotel for which we are creating this database, there can be a maximum of 500 values. So in this table, so or if you know that there will be 1000 values, so it's up to you what minimum and maximum you want to put. Now we are setting it as generated always. So this means that the value of room ID will be generated always by Postgre. So it will always be a system generated values, and if you will put generated default, in that case we can put our own values also. So we want this value to start from 1 and go up to a maximum of 500 with an increment of 1. First value will be 1, second value will be 2, third value will be 3, and so on. Now this much is, after saying this much, after discussing this much, we'll copy this and we'll go to our PG admin. So in PG admin, query window is already open, but we'll refresh this table. After refreshing this table, I will open a query tool here. It will refresh the query tool. I will put this code. Again, all this code will be shared with you so that you can create your own tables. You just have to change the name of columns. You just have to change the data type of columns. Let's say room price cannot be empty, so you have to put not null here. Whatever value cannot be empty, you have to put null here, not null here. And let's say room category can be empty, so we can avoid not null. There are many things that will be discussed in various examples that will come. Everything cannot be discussed in one example, but this is a simple database that we are this is a simple table that we are trying to create in this database. In this table we have room id, room name, room price, room category. Room id is our primary key. It is the identity of this particular table, and this column is identity of this table. It is the main unique identity. That unique, by unique I mean that every column, every row will have a unique value, and we have increment of 1, start 1, minimum value 1, maximum value 1, and so on. So now this table will be created. Let's execute this, and now you can see we have some issue in our SQL statement, and we'll try to fix that. Okay, so the issue is here. This semicolon was placed here. The semicolon should be placed here, not here, because this round bracket is closing here. So after this outer round bracket closes, you have to put semicolon in this case, and because this thing is inside the definition of the table which we are creating, this is just telling something more about room ID, that we are setting a room p key on primary key. Now let's execute this. So now you can see query returned successfully without any error, and now we'll refresh it. So you just saw that you have to place even semicolons at the same places. Now I will save this. So I will provide you this I will provide this code to you so that you can copy this code, and with the help of this code you can create your own tables. This key is correct. Now you can see we have three tables. One is TBL hotel, second is TBL room. Let's refresh TBL room and let's go to its. I will first expand this, and after expanding I will go to the columns, and in columns you can see we have room ID. We have done so much configuration on room ID. We have put some constraint, and whatever constraint we put, you can see they are reflected here. So identity is set as always, increment is set as 1, minimum is set as 1, maximum is set as 500, cache is 1. What is meaning of cache? This is something that we'll discuss later. You just don't need to worry about cache for now. You just have to understand meaning of identity. This identity means this particular column is identity. We have two values always and by default. I already discussed meaning of these two things. Increment is 1, minimum is 1, maximum is 500. It is identity. And now the thing is, now let's insert some data in this particular table. So either with the help of create, we can create more column, and when you will right click on TBL, so you can see you can view or edit data, right? So you can view or edit data, and let's say we want to view all rows. When you will view all rows, select star from table query will be fired. Again, we'll discuss select in separate chapter, so you don't have to worry about this command. Now here you can see when you view data, you see that this particular table is empty here. Okay, there is no value in this table. So in this case we will learn how to insert some data without writing query here. Okay, and before that I will just explain select star from this, then I will explain it in a new chapter also. So suppose you write select star from, then you write the name of that table, tbl underscore room. So select star from table, this simply means we want to see all the records of this table. This simply means see all the records of this table. Suppose you want to see all the records of hotel table, so what you can do, select star from tbl underscore hotel. So this will show you all records of hotel table. We will discuss more about select. So when you will run this, when you will execute this, you will see we will have the same result that we were seeing there. In this case you can see we don't have any data here, so we can edit data, right? We can edit from here, and you will see that I will not enter any value for room id. Let's say room name is SD101. This can be Super Deluxe 101. Let's say room price is, remember what room price I am putting, 4500. I am not writing any decimal or anything. I am writing 4500. And let's say room category is ST. Okay. And now hit enter. So now this is done. Now we have to save this. So you can see here in this icon we have saved data changes. Let's click on this, and now you can see save data changes occurred and one ID was generated. You can see one was generated, and here you can see because we created a decimal here, right? A decimal with 4 decimal points and total of 10 characters. So you can see that we have 4 decimals here with our price. So it's up to you what precision you want. If you want 2 decimals, you can put 2 decimals in the definition. So you can go to room price, you can go to its properties, and in the properties, in the definition, you can see the length precision is 10 and scale is 4. So we can put a scale of 2 here and we can save it. So when you will save it, and let's refresh this, and then we will select a star from room 1 again, once again, and execute this. Now you will see we have a scale 00. That simply means we now have 2 decimal points. So it's up to you what you want and what is the requirement. The one thing that we are seeing here, that we entered SD here, and instead of SD it is character 2, we entered SD, and still it was not saving SD. I don't know why. Let's execute this. So for some reason you can see it is not storing 2 values, although we have character 2. So we will fix this in the upcoming chapters. Things like this will happen, that's why we test our things. So we'll see why it is not saving this, and otherwise we have some values inserted. Let's insert one more value. Let's say it will be SD102. Okay, let's see, the price of this will be same, 4500, and this time let's say it will be DS. Okay, and make changes. So you will see that those values are saved. Just there is some problem in this column, and we will fix this in upcoming chapters. So this is a simple example, and you can see when we inserted the second record, after inserting the second record, you can see we have automatically generated ID of 2 for this primary key. So again, this is simple example. We will come with more complex example. We will fix things like this, and then our database will be perfect. And the more the more important thing is, in this part we created a table with the help of a query. Okay, so either you can create tables with help of queries. Sometimes when we have to write large, when we have to create large tables, and most of the columns have repeated data type and thing, so writing queries can be really easy. So we can write queries, and then we can create data tables with the help of these queries. Or you can use the designer, which we used in previous parts. You saw that. So it's up to you what you want to use, what you are comfortable in. And in the next part we will see how we can insert data without help of this designer here. So here you can see we have this grid here, and we are simply inserting values here. But in the next part we will see how we can write queries, how we can write insert queries for that. So I have my insert queries prepared here. We will see how we can implement that in upcoming chapters. Thanks for watching this. Have a nice day. Hello friends, welcome to another chapter of PostgreSQL. In previous chapters we discussed about constraints in SQL. So the meaning of constraint is a limitation or restriction. These constraints are used to specify certain rules for information in table. These constraints are also used to put limit on type of data that can be inserted in a table or a column. So if you want certain type of data to be inserted in a column and you don't want any other type of data, so for that we can put some constraints, we can put some limit, and with the help of constraints. Constraints can be applied at column level or table level. So in this particular chapter, we are going to learn about primary key constraint in SQL and how we can apply it. We have seen examples of applying primary key or setting primary key, but in this chapter, we'll specifically discuss what is primary key constraint in SQL. So it works as a unique identifier for each record in a table. So whenever we insert some values in a table, all values are inserted in rows. So the more there are number of rows, so for every row there should be a unique identifier, so that we can get information of that particular row, or we can get information between a given range of rows, and various things like that can be done with the help of primary key. There are only unique and not null values in a primary key. There can be only one primary key in the table, but a primary key can consist of single or multiple columns. Primary key with single or multiple columns is known as a composite key. So now we'll see how we can add primary key constraint on an existing table. So we created a table in our previous examples. The table was named as user. It was created in public schema. It had ID and name. It had two columns. ID was integer and not null, but we did not set ID as primary key. And now with the help of alter table statement, we can set that particular value as set any particular column as primary key. So we will the command of alter table is very much simple. You just write alter table, then you write the name of schema, and then you write the name of table. So alter table public dot user, and then you add constraint, and then you give name of your constraint. So because we are adding a primary key constraint, so we'll enter user underscore p key, and then we are writing primary key and ID. Again, this name can be anything. This name is just to identify the constraint that we are applying on any particular table. So either at the time of creating a table, so whenever we create a table, so we can set constraint like this also. So constraint room p key, primary key, room ID. So this we discussed in previous example, where we, at the time of creating a table, we can set that suppose you get some table in which primary key constraint is missing or any type of constraint is missing. So with the help of alter table statement, we can add that constraint later also. Now we have our PG admin ready here. So in PG admin we have schemas. In schemas we have public schema, and in public schema we are now in the users table. So whenever you will expand a table, you will see there is a section of constraint, and in that section of constraint you will see whatever type of constraints are there, you will see them. So you can see a key is a symbol of key is just next to this room p key. That means it's a primary key. So now we will set primary key on user table also. If you will expand user tables constraints, you will see there is no such constraint here. Now we will try to set a constraint using query tool here. So right click on users table, open your query tool, and in your query tool you can set this constraint. Again, what is the benefit of this constraint? Benefit of adding constraint is whenever new records will be inserted in this particular table, whenever new users will be inserted in this table, so you will see that after inserting new users, for every user there will be a unique identifier. So now just alter table public.user means in the public schema in which we have user table, we have to alter that, and how is the alteration going to be? The alter will add a constraint user underscore p key and primary key. It will set primary key on column ID. Again, this is the name of column and it should be present in your table. Now select it and execute it. So you can see query returned successfully. Now when we will refresh the user table, you will see in constraint our user underscore p key, the name which we gave to user p key, has now been created, and now we can go to its properties. So you can see its name is user p key, its definition is on ID. So you can see column is on ID, and on SQL we have nothing. So this way our constraint has now been set. And now if you want to also make your columns auto increment, so for that you can go to the constraint part. Again I am right clicking the particular column, going to properties, going to constraint, and you can see that when we created this table, so at the time of creation we manually set the increment as 1, minimum as 1, and maximum as 10. Let's say there will be maximum 100 users in this table, so you can set maximum as 100. It will be identity, and identity will be always. We discussed about always and by default in previous examples also. In case of always, this particular ID will always be system generated, and in case of by default, this particular ID will, we can also provide a value for this ID, but because we are making it auto increment and we are setting the auto increment here of 1, so there is no need to set it as by default. It will be always be auto generated. So this is how we can set primary key constraint, and in the next chapter we will see how we can insert some data in our tables using the SQL query.